Before we begin, take a moment to get comfortable. Let your arms go heavy, your breath slow. And as you listen, feel free to leave a comment sharing what time it is, where you are, and what city or village you're listening from. It's love to know. And if you'd like more quiet stories like this one, don't forget to subscribe so they gently appear when you need them most. Now, let's begin. You lie in your bed tonight, eyes soft against the shadows, and somewhere in the quiet of your chest, you feel the rhythm of the day slow. Time becomes gentle here. You know how things are supposed to go. First comes a cause, and then its effect. A match is struck, and flame follows. A leaf falls, and then the wind stirs it. You move, and then your shadow moves with you. This is the story you've always trusted. The world is a chain of events, each link forged by the one before it. But the deeper into nature we peer, beyond atoms, beyond certainty, into the trembling fabric of the very small, that story starts to bend. Because in the quantum world, questions don't stay still. Their particles don't act like obedient marbles or tiny balls. They shimmer like maybes. They dance between possibilities. And sometimes, most strangely of all, the outcome of an event seems to depend not on what happened, but on what you decide to find out later. It starts with light, a beam of light broken down into individual photons, those tiny packets of energy that flicker through the universe like the most delicate of messengers. Imagine one photon, just one. It's nothing more than a whisper, a flick of probability. And now, imagine sending that photon toward a screen with two slits. You'd think it would go through one slit or the other, left or right, this or that. And if you measure which slit it goes through, it does exactly that. It chooses. You get an answer. The world solidifies. But don't ask, don't look. Just let the photon pass through the slits and land on the screen behind. What appears is not a pattern of choices, but a pattern of waves, interference, ripples, as if the photon had split in two and gone through both slits at once, interfering with itself, like a ghost of a decision that was never made. And this is where your breath catches. Because it's not that the photon traveled through one slit and you just didn't know which. It's that, until you asked, until you measured, it hadn't chosen. It wasn't one thing. It was every possibility curled into a single path. Your decision to ask changes the past, not like a movie, not with time machines or rewind buttons, but quietly, elegantly. The past, it seems, is not fully fixed until you interact with it. And that's the beginning of the question that won't stay still. What happens when your choice in the present can change how the past behaved? There's a name for these kinds of riddles. Call them quantum eraser experiments, because they let us ask the universe a question, then choose whether to erase the answer and see reality behave differently depending on whether we do. It's not about magic. It's about information. Whether something can be known, not even whether it is known, changes the behavior of the entire system. That photon, if you arrange things so that you can know which slit it passed through, even if you never look, the interference pattern disappears. The wave collapses. The photon behaves like a particle. A decision was made. But if you set things up so that it's impossible to know, even in principle, then the wave returns. The dance continues. So the photon doesn't respond just to the world around it. It responds to the structure of the question being asked, and even to the structure of questions not asked, but possible. And you are the one who decides, not with willpower or control, not with drama, just by looking or not. This is the strangeness at the heart of quantum mechanics, is that the act of observation, of attention, doesn't just see the world. It helps to make it, not by imposing, but by closing the loop between what is and what is known. And so, tonight, lying in your bed, you wonder how much of your day, your choices, your memories, unfolded simply because of where you placed your attention. What if the universe you walk through is not the only version that could have been, but the one that crystallized under your gaze. It's hard to accept. You've been taught that reality is objective, stable, indifferent to you. Tease. But the quantum world is not indifferent. It is curious. It waits. And while this effect plays out in experiments with photons and atoms, you begin to feel its echo in the folds of your own life. When you remember a moment, do you remember it as it was, or as it has become in your retelling? When you notice someone's kindness, did they become more kind? Did your attention light up something that might have gone unseen? There's no need to stretch the science. The quantum experiments stand on their own, but they ask us to rethink what it means to know, to choose, to see. And they leave us with a gentle, thrilling possibility that even the past might not be fully written until you step into it with a question. So tonight, you drift further into stillness. Consider this. What answers wait for you? Not in what you already know, but in what you are about to wonder, and what might change softly as you begin to ask. There's something quietly magical about a single beam of light. You've seen it before, streaming through a window at dusk, catching dust motes in midair like tiny stars drifting through a soft gold current. It feels peaceful, predictable, but underneath that stillness, light holds secrets so subtle. They rewrite the way we think about existence. To begin, you picture a simple scene: a wall, a source of light, a barrier between the two with two narrow slits cut into it. Behind the wall, a screen waits to catch whatever slips through. It seems innocent enough, but what happens in this small setup has puzzled scientists for centuries. This is the famous double-slit experiment. Elegance is matched only by its quiet rebellion against your sense of what's real. You imagine firing small particles, photons of light, or even electrons, one at a time, toward the slitted barrier. If each particle behaves like a tiny marble, you'd expect it to pass through one slit or the other and hit the screen accordingly. And if you repeated this, a pattern would emerge to clear bands on the screen, each one showing the trail of particles that passed through one of the slits. That's what logic suggests. That's what your intuition clings to. But that's not what happens when you let the particles fly without measuring which slit they go through. They land in a pattern that makes no classical sense. They don't form two bands, but many like ripples in a pond. It's an interference pattern, as if the particles are not behaving like marbles, but like waves. Waves that pass through both slits simultaneously and interfere with themselves. It's as if each photon, the smallest packet of light, travels every possible path at once, splitting and overlapping, weaving its own possibilities together, into a quiet tapestry of chance. And then you try to peek. You set up a detector at the slits to find out which path each particle takes. You want to know, did it go left or right? The interference pattern disappears. Instead, the particles land in just two simple bands, as if they have decided to become marbles again. The act of observing collapses the wave. The moment you know which slit the photon passes through, it stops acting like a wave of probabilities. It becomes a single history, a single fact. It behaves. This is the soft secret of the double slit. The pattern changes based on whether you ask the question, not whether you interfere with the particle knot, whether you push, pull, or disturb, merely whether you watch. Whether the system is arranged in a way that allows for the information to be known. You are not influencing the particle by force. You are shaping the context of its reality by changing what can be known about it. And so, the universe whispers back a question of its own. What else might change? Simply because you pay attention. You feel the weight of that thought, not heavy, but profound. In your life, too, there are moments that seem to shift depending on where your attention lands. A stranger's face in a crowd that looks different once you notice their eyes. Memory that sharpens or blurs depending on how often you revisit it. A feeling that deepens simply because you pause to feel it. The double-slit experiment doesn't suggest you control reality, but it hints at something even more intimate, that reality, at its smallest level, is unfinished without you. It arrives in layers, some fixed, some fluid, and your presence helps shape which ones emerge. This idea unsettles classical thinking. For centuries, science assumed the universe ticked like a grand machine, objective, predictable, and different to observers. But in the quantum world, the observer is not outside the system. You are part of the story, and it all begins with a slit, with a screen, with light. You rest deeper into your pillow now, eyes closed, but your mind stays lit by the soft flicker of that experiment. You imagine the particle again, alone, unaware of being watched. And so it spreads left and right, both paths open, neither chosen. It travels as a probability, a maybe, a wave of potential dot, until someone watches. Then it collapses. The wave disappears, and what could have been becomes what was. This moment, that shift from possible to real, is called wave function collapse. It sounds like something sudden, dramatic, but perhaps it's quieter than that. Taps is not so much a collapse as it is a settling, congealing into dew, like a decision softly made. You wonder, how many times today did something settle because you noticed it? How many actions turned to memories the moment you reflected on them? How many thoughts, drifting like probabilities, became real just because you gave them space? There is beauty in the idea that you're not just a witness to the world, but a participant in its becoming. Not in a grand or mystical way, but in the smallest of ways, the quiet role of the observer. And now, a final curiosity tugs at the edge of your thought. If observing a particle can change its behavior, what happens when you try to undo the observation? Can you erase the fact that you knew? Can you return the system to possibility? That is where this story leads next, to a deeper experiment, to a particle that has already passed through the slits, already landed, already been observed, and then, gently, unobserved. You'll find that in the quantum world, even the past has soft edges. There is a soft power in your gaze, a quiet ripple that moves through the world, even when you think you're just watching. You don't lift a finger, you don't speak a word, and yet your presence changes things, not metaphorically, physically, in the realm of the very small, where particles float like whispers, and time feels more like a suggestion than a rule. To observe is to interfere, not with force or disruption, but with knowing. Here, the line between witness and creator blurs. You return, in thought, to the double-slit experiment, that place where particles behaved as waves, unless you looked, unless you measured, and then they chose a path, chose a shape, chose a story to become. But what does it mean to measure something? It's not just pointing a camera or holding up a ruler. In quantum mechanics, a measurement is any interaction that makes a particle commit to a place, to a path, to a position. Before that, it exists as a blur of maybes. After that, it is a single was. The act of measuring doesn't simply reveal reality, it helps construct it. In the quiet of your room, you begin to see parallels. A child performs differently when they know they're being watched. A dancer becomes more precise under the theater lights. A thought grows clearer at the moment you try to write it down. When you observe, you don't just record, you shape. This is not a romantic idea, but a mathematical one. In the quantum world, equations describe particles not as things, but as probability distributions, clouds of likelihood, shadows of presence. And yet, when you observe, the cloud collapses, the particle appears. One path becomes real, and all others fade into soft impossibility. Why? No one knows for sure. Some physicists say the wave function collapse is just our ignorance folding. Everything was already there. We just couldn't see it. Others suggest that reality itself is indeterminate until observed. That things truly become when noticed. You let the mystery breathe, and then you wonder, what does it mean for your life? Is there such a thing as emotional wave function collapse? You remember the feeling of brushing past someone you love, distracted, half present, unaware, and then you recall the time you stopped, looked into their eyes, and truly saw them, how different the world felt, how the moment changed. How you changed. To observe with attention is to bring something into fuller existence. This is not magic. It is mindfulness. The quantum world, strange as it may be, seems to reflect that insight, not by analogy, but by rule. And still, the mystery deepens. You learn of quantum entanglement, that eerie connection where two particles become linked across space. What happens to one affects the other instantly, even if they are galaxies apart. And more strangely still, the observation of one particle can determine the state of its twin. It's as if the universe waits for your glance before deciding which version of itself to become. What, then, is the role of consciousness? Interpretations of quantum mechanics, though controversial, suggest that awareness itself may be part of the equation, that without an observer, the universe remains undecided, unformed, quietly waiting in a state of possibility. You breathe slowly, carefully. That thought is too large to hold all at once, and yet something about it feels familiar. Think of dreams left unwritten, art unattempted, paths not taken simply because no one looked. No one believed enough to see. Attention, then, is an invitation. A yes, a way of saying, become. You wonder if the world responds to your gaze in ways more subtle than physics can measure. Maybe in the arc of a leaf's fall that you alone witnessed. Maybe in the way a memory shapes itself differently every time you return to it. Maybe in the moment a stranger felt seen and smiled. You are not just a passenger on this timeline. You are also a shaper of its texture. In the quantum world, particles are slippery, elusive. They can be here and there, wave and particle, possibility and presence, until you measure, until you look. Then the dance ends, and the particle bows into form. It is not a choice you make on purpose. It is not control, but it is collaboration. So you ask not for the answer, but for the comfort of the question. What else might settle into clarity if you simply noticed it? What thoughts remain in a fog of potential, waiting for your attention to become real? And what versions of yourself have yet to take form? Not because they're impossible, but because you haven't looked in their direction. Not everything needs your gaze, but some things only arrive when invited. You sink deeper, now, into warmth, into the gentle weight of the blanket, into the rhythm of this unfolding truth. Observation changes everything, not by force, not by power, but by presence. You are not just a witness of reality. You are its quiet creator. And as you drift, one last idea floats toward you like a question on a breeze. If observation decides the shape of the present, what happens when you erase what you've seen? What if you could erase the which path information after the particle has already gone through? The interference pattern comes back, as if the choice was never made. You didn't change the past, but you changed whether the past mattered. Can something be both true and not, depending on what you choose to know? In the world, time flows in one direction. The past is settled, and the present moves in its wake. But in the quantum world, time has a gentler flow. It slips and stretches, bending under the weight of your observation. Here, reality is not a fixed line, but a momentary pulse, shaped by choices you haven't yet made. The quantum eraser experiment offers a glimpse into this soft mystery, where the past is not so certain, and the present moment holds more power than you think. Imagine, if you will, a quiet room. In the center, two paths are set before a particle. One path leads through a bright, distinct marker, and the other through a shadowed gap. In an ordinary world, if you were to observe which path the particle took, you would know. You could say, it went this way, or it went that way, with no room for uncertainty. But in the quantum world, the particle exists in a haze of possibility, neither here nor there, until you, the observer, make a choice. You are the one who breathes life into its path. Till you look, it has no true position. It is, in a sense, both paths at once, scattered across both. It is only through your gaze that it chooses. But what if you didn't have to look immediately? What if, after the particle has already gone through, you could choose to erase the information about which path it took? Would that change the particle's journey? Would it undo the moment of decision? This is the essence of the quantum eraser, a setup designed to undo the knowledge of the path after the particle has already traveled. By erasing the information of its route, the particle once again behaves as though it existed in a wave of possibilities, never having chosen a single path. The interference pattern, the delicate dance of waves, returns as though the choice was never made at all. But this is not time travel. It's not as if the past has been rewritten. The past remains exactly as it was, an unbroken sequence of events. What has changed is the importance of that moment in time. The information that was once captured, that you knew which path the particle took, no longer matters. In the quantum world, what is known can influence how we perceive what has already happened without changing what truly occurred. You didn't alter the past, but in erasing the choice, you have shaped the present perception of it. The history of the particle is not fixed. It is as flexible as the knowledge you have of it. The very act of erasing the knowledge changes the way the present reality is experienced. It is a soft reminder that in this world, knowing and not knowing, remembering and forgetting are all part of the dance of existence. But why does it matter? Why does this delicate question of knowing and not knowing influence what we observe now? If the past is truly untouched, then what is it about the act of observing or not observing that weaves its threads into our present? It suggests that reality isn't a single thing, but many threads woven together. And the act of untangling one thread changes the shape of the entire weave. This realization is delicate, gentle, like the passing of a breeze. It invites you to ask, can the past be something more fluid, shaped by our choices even as it remains behind us? The quantum world softens time, folds it, and reveals that the fabric of reality is not as simple as it seems. As you continue to consider this, you might wonder if information can be erased. Does that mean reality itself can be shaped by the choices we don't yet know we'll make? The quantum eraser shows us that the boundary between what is and what could be is not as clear as we might have believed, and so you're left with a quiet question, one that hums softly in the background of your thoughts. If you could erase your own path, could you change how you see the choices you've made in your own life? The gentle world of possibilities awaits as the next chapter reveals the ripples of time. Where your choices today reach across the vastness of the universe. John Wheeler imagined a cosmic version of this experiment. A photon from a galaxy might decide what it was long after it began its journey. Your measurement now determines what it was millions of years ago. What does that say about your place in time? The night sky stretches above you like a memory. Light from stars long dead pours into your eyes, soft and quiet, as though time itself is whispering. You are not just seeing now, you are receiving messages from the past. But in the world of quantum physics, even this sense of past is unsettled. The moment of now, the moment you open your eyes, might ripple backward. John Wheeler, with his quiet, dreaming genius, dared to ask, what if the universe doesn't decide what happened until you look? This is the idea behind the delayed choice experiment. A photon, a single grain of light, travels across the universe, perhaps from a galaxy so far away that the Earth did not yet exist when it began its journey. Along the way, it comes near a gravitational lens, bending around a distant star or cluster, which splits its path in two, like the double-slit. Experiment. The photon has a choice, but it is a silent choice, hidden in the folds of spectrum. Now imagine this. You set up a detector to catch the photon as it arrives on Earth, but you delay your decision. You delay whether you will measure which path it took, or whether you will allow the interference pattern to form, meaning the photon must have taken both paths, like a wave. You decide not when the photon is in motion, but long after it has already passed the place where it chose a route. And yet, your choice made now, after the photon has finished its journey, determines what kind of particle the photon was millions or even billions of years ago. If you choose to look for which path it took, the photon behaves like a particle. The interference pattern disappears. It must have chosen one route. But if you choose instead to allow interference to preserve the mystery, the photon reveals itself as a wave, having gone both ways, no matter how vast the cosmos it crossed. The past, in this experiment, becomes a story you tell based on your current perspective. The photon's history bends around your present choice. You do not alter the photon's true journey. It always arrived, but you decide what that journey meant. The photon was not one thing until you looked. It is as if the universe holds its breath, waiting to find out what you will do, John. Wheeler's vision was not a trick or a philosophical game. It was a proposed experiment that scientists later carried out, and it worked. Reality responded to a delayed question. It's as though the cosmos keeps its records unwritten until the right page is turned, until you ask, until you care to know. And this is not just poetic. In quantum mechanics, reality depends not on the past alone, but on the entire experimental context, which includes what you choose to measure now. The universe is participatory, not in a mystical sense, but in the deep, logical structure of quantum theory. The act of asking a question shapes the conditions for the answer. The act of deciding what to observe creates the frame in which nature responds. It leads to a strange kind of responsibility. A photon launched long ago does not seem like your concern, and yet, in a delayed choice setup, your present is part of its story. Your gaze, your choice to know, echoes backward. What does that mean for your place in time? Perhaps you are not simply a passenger on a one-way ride. Perhaps your attention, your curiosity, your willingness to wonder, these are not just passive states. They participate in shaping the meaning of what has been. You don't control the events, but you co-author their interpretation. Think of all the small photons in your life. Words once said, moments once lived, choices once made. They are all still flying through your inner sky. And perhaps what you choose to see in them now changes their meaning. This is the quiet revolution of delayed choice. Not the rewriting of history, but the reweaving of what that history means. The universe becomes not a fixed story, but a living poem, one that waits for your line before it knows its rhyme. And so, you lie beneath the sky, wrapped in light. That began before you, but which now, in this breath, becomes part of your own becoming. You are not separate from this process. You are the reader, the observer, the late decider. And softly, this invites one more thought. A particle is not one thing or another. It is both, waiting to be asked. The quantum world wears many masks, switching softly as you look, but it hides nothing from itself, only from you. What parts of your life feel different depending on how you choose to look at them? You sit quietly. The world is still, and somewhere in that stillness, a single particle moves. It is not a ball rolling through space. It is not a wave splashing on the shore. It is not even a thing in the way you usually imagine. It is, instead, a possibility, a shimmering maybe, a softly closed curtain that waits to be drawn back. You may want to ask, what is it, really? But the answer is slippery. It depends not on the particle itself, but on how you choose to look. In quantum physics, the identity of a particle, whether it behaves like a wave or a discrete point, is not something it carries with it from the beginning. It is something it reveals at the moment of observation. Before that moment, it is not pretending, nor is it undecided. It is simply undefined. Okay? The wave and the particle are not two costumes it changes into. Te are reflections of your questions. Imagine a curtain drawn across a small theater stage. Behind it, a dancer waits, not rehearsing, not preparing, simply waiting. The nature of the dance will depend on the music you choose to play. Play one rhythm, and the dancer emerges in flowing motion, a wave across the floor. Play another, and the dancer steps precisely, cleanly, each footfall a sharp mark in time. But before the curtain rises, neither form is real. Both are possible. And the dancer knows both intimately. This is the essence of quantum ambiguity, not confusion, but coexisting potential. A particle is not one thing waiting to be revealed. It is many things waiting to be asked. The wave-particle duality is perhaps the most famous mystery in quantum theory. It tells us that matter, the very substance of reality, is not fixed. It responds to attention. If you measure a particle's position, it becomes a particle. If you ask about its interference, it becomes a wave. And if you do not ask, it remains hidden, not because it is secret, but because it has not yet been shaped. You might ask, how can something be both? But the deeper truth is, it is neither until you join in. This does not mean the universe is vague or unreal, right? It means it is participatory, like a piece of music that doesn't exist until it is played, but which always had the potential to be heard. Physicists have built entire experiments around this curtain of ambiguity. In one, called the Mach-Zehnder interferometer, a photon travels through a beam splitter, a device that sends it along two paths. If both paths are allowed to remain open and unmeasured, the photon shows wave-like interference. It interferes with itself, as if it split and traveled both paths simultaneously. But if you introduce a detector, it's a gentle observer who quietly records which path the photon took, the interference disappears. The wave collapses. The curtain lifts to reveal only a single step in a single direction. The difference is not in the path, but in the knowledge of it. The quantum world does not seem to decide on a truth until the question is posed. It wears a mask that responds to your gaze. Once you look, the mask becomes the face, not because the particle was hiding something, but because it only had a face in relation to your attention. What does this mean for you? It suggests that some aspects of your own life, your memories, your emotions, your stories, may also wear masks, not because they are deceptive, but because they change shape depending on how you view them. A moment remembered with love may feel different than the same moment recalled with regret. A choice long past might seem brave in one light, foolish in another. Neither view is false. Both are part of the deeper wave that underlies your experience. There are truths that only appear when you are ready to see them, and there are possibilities that remain folded, like light behind a curtain, until you ask the right question. Perhaps the universe is not so different from the inside of your own mind, layered, responsive, quietly waiting for the shape of your attention. This chapter, then, is not just about particles and waves. It is about the space between what is fixed and what is fluid, about the line you draw, knowingly or not, between fact and interpretation. It invites you to imagine that reality is not a wall, but a mirror, shifting softly with your presence. And now, the path opens further. Two particles become linked, their fates tied beyond space and time. What happens to one instantly affects the other, even far away. Quantum eraser setups use this connection to reshape what was, what invisible threads connect you to. someone else's quiet choice. Picture two tiny particles, born from a single spark, then drifting apart. One moves left, the other right. They may travel for light years in opposite directions, yet something unspoken binds them. They do not forget each other. In fact, it seems they cannot. Whatever happens to one echoes in the other instantly, even if they're separated by galaxies. This is quantum entanglement, a quiet, invisible thread linking particles across space and time. Einstein called it spooky action at a distance, but today, physicists no longer doubt it. They measure it, harness it, and listen to its strange rhythm. At first, it feels like magic, but it isn't. It's simply a different kind of intimacy, one that exists not in space, but in information. When two particles become entangled, their properties intertwine. If you measure the spin or polarization of one, the result you find determines or reflects the result of the other. But this doesn't mean one causes the other. It's more like opening to matching letters from the same envelope. Each contains a message that only makes full sense when you read both. Entanglement isn't about signals traveling faster than light. It's about shared origin. It's about a deeper structure beneath space, where distance doesn't matter in the usual way. What's surprising isn't that the particles remain in sync, but that their connection persists, even when they're no longer near each other in space, or even in time. Now enter the quantum eraser again, but with a twist. In some versions of the experiment, entangled particles are used. One particle travels through a setup, perhaps a double-slit or an interferometer, while its twin goes somewhere else entirely. You measure the second particle in a certain way, sometimes gathering which path information, sometimes erasing it, and depending on that choice, first particle already detected shows different behavior. This means that a decision made on one side seems to reshape the pattern on the other. After the fact, the past that has already happened bends under the influence of a later, distant choice. Not because anything traveled between the two, but because they were always part of the same question, and your answer arrived in two places. It's difficult to express how gently mind-bending this is. It's a pattern, the very signature of eerie signature. What the first particle did depends on whether the which path information was preserved or erased for its partner, and that decision can be made after the first measurement is done. You can feel the fabric of causality stretch here, not break, but stretch. It's not that you've reached into the past and rewritten what happened. It's that what happened wasn't settled in the usual sense until all parts of the experiment came together, even the ones far apart in time and space. The story was incomplete without the ending, and the ending wasn't known until you arrived. Entanglement tells us something simple and strange, that the parts of the universe are not truly separate. That information binds, so that a shared beginning can link to things so closely. They remain mirrors long after their separation. But maybe this isn't just about particles. Maybe it's about you. 2. What moments in your life feel entangled? Not by cause and effect, but by meaning. What people echo in you, even from far away, whose quiet decisions, made long after your own, reshape how you see your past. Entanglement doesn't imply control. It implies correlation, the kind that exists in deep relationships, unspoken connections, silent recognitions. You can't use it to send messages, but you can use it to understand that everything is more connected than it seems. And sometimes, understanding that a connection exists, even if you don't know how or why, is enough. So you sit with this idea that parts of your own past may still shimmer with uncertainty, and that someone else's gentle choice, perhaps long ago or far away, might cast light on a moment you thought was closed. In the quiet space between events, in the pauses between particles, in the silence between two entangled beings, something still lives and listens. In quantum physics, information is everything. What is known, or could be known, defines what is. Erasing information can bring something unhappened back to life. What forgotten detail would change everything if remembered? In your world, you think of information as something separate from things, a note, a memory, a detail written on paper. But in the quantum world, information is not just a label on reality, it is reality. Everything that happens, every particle, every wave, every outcome is shaped not only by physical laws, but by what can be known about it. This is not a metaphor. It is the foundation of how nature unfolds on the smallest scales. Information is not decoration, it is structure. It's the skeleton of being. Take, for example, a single photon in a double-slit experiment. If there is information about which path it took, even if you never read it, even if it simply exists in the background, the interference vanishes. The wave is gone. The photon behaves like a particle committed to a single route. But if you erase that information, if it is no longer possible to know which path was taken, then the wave returns. The interference reappears. The past, in a sense, is resurrected in a new form. And this is the heart of something quiet and strange. Erasing information undoes the effect of its potential. The quantum eraser shows that the availability of knowledge, not just the act of looking, determines the outcome. It is not your eyes that shape reality, but the very possibility of knowing. It's a shadow of a question. It's a presence of an answer, even unanswered, is enough to alter what is taught. It is as though the universe listens not to what you see, but to what could, in principle, be seen. This means that the boundary between reality and memory grows thin. A particle's path, your own past, the structure of the moment. These things are not hard lines, but outlines drawn by information. When the outlines shift, so does the shape within. And in this gentle reweaving of what is, comes a deeper idea. Information cannot be destroyed. In physics, this is more than belief. It is principle. Even in the black holes that swallow stars, the law of information preservation whispers that something must remain, that what has been known, even for a moment, must echo somewhere. This is called unitarity, the idea that the total information of a system is conserved, even when it transforms. Nothing is truly lost, not fully, scrambled, hidden, tangled with things you can no longer reach. It is this idea that underlies the strange reversibility of some quantum processes. You can unhappen a choice, not by going back, but by erasing the trace. As if the universe says, if no one remembers, it didn't really occur, but it did. And it didn't. It hovers. How many things in your own life live in that same soft threshold? Moments, half remembered, ideas, glimpsed, and forgotten, choices buried beneath time. The trace of them might still remain, not in your conscious mind, but in the structure of your path, in the directions you quietly took. What if, like a photon's path, your life holds interference patterns of forgotten information? A conversation you half recall, sentence that shaped you, though you don't remember the words. The knowledge might be erased, but its echo remains, not in memory, but in shape. Like waves rippling through you. And what if retrieving that information, even imperfectly, could reshape how you now move through the world? In quantum experiments, this is not just theory, it's real. Physicists use entangled photons to restore lost interference by erasing which path information. The pattern, the memory of possibility, returns, as though the universe carries a kind of forgiveness, a quiet allowance. You no longer insist on the past being fixed and known. You are allowed to recover the fluidity of what might have been. This does not undo pain. It does not erase facts, but it loosens the grip of certainty. It allows a memory to stretch, to shimmer, to open again. Information is more than detail. It is what gives form to time, to matter, to choice, and perhaps to you. So now you wonder, not just what you know, but what you could know. What hidden trace if revealed or erased, would bring back a possibility you thought was gone, and somewhere deeper still. What possibilities are waiting to exist, if only you forget the right? Think. At first glance, the quantum world appears chaotic. A photon lands here or there. A spin is up or down. An atom decays or does not. To the untrained eye, it seems as though nature is throwing dice, unblinking, unconcerned, perfectly indifferent to your hopes for order. And yet, look closer, and you begin to see something else. In the forest of randomness, a quiet pattern lives, not in the outcome of any single event, but in the shape of many, like raindrops falling unpredictably, but forming a puddle in a predictable place. Quantum mechanics lives in this in-between space, where each event is uncertain, but the overall tapestry is not. You might hear it said that the universe, at its core, is random, that particles behave unpredictably, that decay and spin and momentum cannot be known in advance, okay? And this is true to an extent. The rules of quantum physics offer only probabilities, okay? They tell you what might happen, not what will. But that doesn't mean the world is without structure. Quite the opposite. Because when you prepare the same experiment again and again, hundreds, thousands of times, patterns appear. Fringes of light, statistical curves, regularity emerging from uncertainty. The quantum world is not lawless, simply expresses its laws in the language of chance. And in that language, your role as an observer becomes more than passive. You are not choosing the outcome. You are choosing the context, the question, the shape of the possible dot in quantum experiments, the way you set up the apparatus, the beams, the detectors, the erasers, or filters, defines the framework in which outcomes will play out. You are not a puppeteer pulling strings. You are a composer, setting the key and tempo, and allowing the music to unfold, and the particles respond, not to your will, to the boundaries you draw. This idea that you do not control reality, but help complete it, is soft and profound. It returns again and again in quantum theory, okay? In the double-slit experiment, in entanglement, in quantum erasers, and delayed choice. You are not the cause of what happens, but the condition under which meaning arises. The pattern includes you. This does not mean your thoughts shape the world. It means your participation matters, okay? That the setup you choose becomes part of the outcome's story. The randomness is not wild, but framed. Like a tree growing into the shape of the cage it finds itself in, and this quiet truth might echo beyond physics. In your own life, you may see randomness, coincidences, surprises, things that land far from your expectations. But when you step back, when you observe with patience, you begin to see the rhythm beneath the noise, the repetition of certain lessons, the reappearance of familiar shapes. You may not control what happens, pwned, but you shape the frame in which things are allowed to happen, the relationships you nurture, the questions you ask, the thoughts you hold gently, again and again, okay? These are not forces, but forms, okay? And reality pours itself into form. In quantum experiments, when scientists alter a detector or add an eraser, they're not changing the particle's decisions. They're changing what can be revealed. The pattern emerges not because of control, but because of care, and because of consistency. And you, too, in your own strange lab of living, set up patterns without even knowing. What you attend to grows. What you ignore fades. What you repeat becomes visible. Your gaze, like the quantum observers, doesn't dictate the outcome, but it makes outcomes meaningful. Even randomness, over time, becomes a message. The physicist John Archibald Wheeler once said, "We are participators in bringing into being not only the near and here, but the far away and long ago." He wasn't being poetic. He meant that reality, even the parts that seem done and distant, takes final shape only when the whole pattern is seen. And sometimes, your role in that pattern is simply to notice, to witness, to ask gently, to hold a question long enough for the answer to appear, not in a single flash, but in the soft return of a shape across time. So now, the randomness seems less lonely. You are not the cause. You are not the conclusion. But you are the rhythm. When you think of the past, you imagine a fixed thing, solid, sealed, quietly resting behind you. It has happened, and nothing can change it. A road already walked, a stone already placed, sentence already spoken. But the quantum world tells a softer story in some interpretations of quantum mechanics. The past is not fixed until the present asks for it, just like a particle doesn't have a definite position until it's observed. Some theories suggest that even its history, how it got there, remains fluid until you decide what kind of question you're asking now. In this view, the past is not a single line, but a branching tree of possibilities. The present moment chooses one of those branches to walk back on, and all the others, like faint ghost paths, remain unexplored, not unreal, just unchosen. This idea may sound strange, but it has a gentle logic behind it. In delayed choice quantum eraser experiments, the act of erasing or preserving information after the particle has already arrived determines whether it must have taken one path or both. The path it took becomes meaningful only now. Its past behavior is not retroactively changed. Rather, which version of the past applies depends on the context you create in the present. You are not rewriting history, you are selecting it. And here, the metaphors grow intimate. Think of a memory, one that feels settled. Maybe it brings you pride, maybe regret. But imagine looking at it from a new angle. Imagine learning something you didn't know back then, something about the people involved, the circumstances, or yourself. That old memory reshapes, not the events themselves, but the meaning of them. The shape of your story shifts. Path you thought you walked turns into something else. This isn't imagination, it's recognition. A new selection, a new branch, revealed in the light of today's awareness. And so it is with quantum pasts. Each interaction in the quantum world is a question and a response. But sometimes the question arrives late, after the response. And still, the answer changes shape. Some physicists suggest that instead of there being one definite history, Atia, there are many, all valid, all quietly waiting. The one you experience is the one that fits the whole picture best. Not the one that always existed, but the one that now makes sense in this view. The past and the present co-author each other. Imagine it, a world where what once was depends on what now is, where the tree of time grows both backward and forward, not fixed, but flowering. This doesn't mean you can undo what happened, but it does mean that meaning is not static, that your understanding of what was is alive, reshaped by your ever-changing now. And this matters, because if there's no single past, only possible ones, then forgiveness becomes more than a feeling. It becomes a rearrangement of history, not in fact, but in form. You can choose to walk a different memory, to follow a different emotional path through what once was. You do not forget the facts, but you select a new frame in quantum mechanics. This is called consistent histories, the idea that the universe allows many possible accounts of how an outcome came to be, as long as they don't contradict each other. Each is complete. Each is internally true, but only one is seen at a time, just like in your life. And so you begin to wonder, what memories have you mistaken for monuments when they were always more like paths, waiting for you to walk them differently? You may never travel back in time, but with each breath, you choose how to carry it forward. And maybe, just maybe, the past you remember is not the only one that could have been true. It's just the one that fits the story you tell today. There comes a point in every quiet evening of thought where the facts settle down, and what remains is story, not fiction, but something gentler, a thread you follow through the woods of uncertainty. In quantum physics, that moment arrives when you ask not just what happens, but why. Not just how the math works, but what it all means. And here, the answers divide like light through a prism. The equations of quantum mechanics are solid, predictive, tested in countless experiments. The interference patterns, the entanglements, the probabilities, they repeat with perfect precision. But the story behind them, the why of the whole shimmering dance, still open. Physicists call these stories interpretations. And though the math remains unchanged, the meaning it carries can differ wildly depending on which lens you choose to look through. One of the oldest and most well-known is the Copenhagen interpretation. In this view, a particle does not have a position or a momentum or even a path, not until it is measured. Observation causes the wave function to collapse. Reality resolves itself when you look. The universe is a question waiting for a witness. Then there's many worlds, a bolder voice. It says, the wave function never collapses. Every possible outcome happens in a branching infinity of parallel universes. When you measure a particle, you don't make it choose. You split, become two versions of yourself, each seeing one outcome, each real. Reality does not collapse. It grows. Or consider the pilot wave theory, which whispers of hidden order. In this view, particles always have definite positions, guided by a wave, a subtle, unseen pilot that determines how they move. There is no randomness, only hidden rules. The mystery is not in the particle, but in the depth of its map. Then comes time-symmetric interpretations, where the future and past are equal partners. The present is shaped not only by what came before, but by what lies ahead. The photon's journey is not a straight line, but a loop, a handshake between times. Your choice of measurement now can help determine the conditions that must have been true before, and there are others still. Relational quantum mechanics, where facts exist only in relation to observers. Cubism, where the wave function is not an object, but a tool, a reflection of personal belief and experience. A map, not a territory. Each of these interpretations offers a complete picture. Each aligns with the math. Each fits the data. And yet, they contradict one another, which is real. The strange and humbling answer is, we don't know, and we may never know, because they all predict the same results. They differ only in the stories they tell about what's really going on underneath, in the laboratory. This doesn't matter. You build your detectors, run your tests, and the particles fall, where the equations say they will. But as you lie here tonight, beneath the soft canopy of unknowing, the question grows more personal. What story do you carry when truth is not unique? Do you find comfort in the idea that the universe becomes real when you touch it? Or does it feel more honest to imagine countless worlds unfolding beside this one, every choice lived, every path taken? Do you believe the future helps shape the past, or that everything flows from some deeper wave, steady and unseen? Perhaps it doesn't matter which you choose, only that you know you're allowed to choose. That in this moment, even without proof, you can sit with the mystery and feel it soften into meaning. In quantum mechanics, this openness is not a flaw. It is a space for curiosity, Room with many doors, none of them locked, because sometimes a question without a single answer is more powerful than a truth carved in stone. And sometimes, when the world refuses to explain itself completely, it offers something else instead, an invitation to wonder. So now you ask, not what is true, but what is true for you. And that answer too might change over time, folding gently into the next ripple of thought, the next quiet turn of the universe's page. You've been taught to think of time as an arrow, sharp, straight, moving forward, from birth to breath to stillness, from morning to night, from cause to effect. It feels so certain, this line. It moves with you, carries you, and will never turn back. But under the surface of that feeling lies another rhythm. One the quantum world quietly reveals. In the equations of physics, time doesn't have a preferred direction. The fundamental laws, whether for particles or planets, work just as well backward as forward. If you filmed a single photon and played the tape in reverse, nature wouldn't mind. There is no built-in forward, only symmetry, and in that symmetry, something beautiful unfolds. What if time isn't a line, but a loop? Not a strict circle, but a spiral, soft, breathing, curving back as it stretches forward. In this shape, the past and future are not strictly separated. They can speak to one another. They can meet. This idea is not just poetic, okay? In quantum theory, some interpretations allow events in the present to influence the probabilities of the past, not by changing them, but by selecting among them, as if the future whispers to the past, choosing which version fits best. One such framework is called the two-state vector formalism, okay? Way of thinking where a quantum system is described, not only by its history, but also by a future boundary condition. One wave flows from behind, one from ahead. The present is their meeting point. Reality, in this view, is not just shaped by what came before, but by what comes after. It's not time travel, it's time resonance. You feel this sometimes in your own life, don't you? A moment long gone suddenly changes shape because of something that just happened. A conversation from years ago takes on new meaning in the light of today's experience. A memory once quiet becomes vivid because of a new feeling, a new realization. It's not that the memory changed, it's that your present touched it, recolored it, reached gently back. If time is a loop, then these echoes are not tricks of emotion. They are part of the structure. You are not moving down a track with past behind and future ahead. You are in a field, a soft, ever-breathing field of now, in which certain paths rise and glow when you turn your gaze a certain way. Physicists have found that in some delayed choice experiments, the interference pattern, or lack thereof, depends on whether future information will be preserved or erased. The outcome now seems to carry a shadow of a future act. Not because anything travels back, but because time, in the quantum world, is not firmly compartmentalized. Events don't sit in a row. They form a whole in your awareness. The way you ask, the way you care, stitches them together in a shape you call your life. Even entropy, it's that great marker of time's direction, is only a tendency, not a rule. But the universe favors disorder. But locally, in small places like hearts and minds and particles, reversals are allowed. Moments can unfold softly, out of order. So if time is not a line, but a loop, if the past can be touched by the shape of the future, then what? Does that make your present? It makes it central, not in the sense of importance, but in the sense of location. Okay, this now, this breath, is not just a result of before. It is also a seed of what was, quiet creator of what has been remembered, and maybe, then, healing. Is real, maybe the way you choose to live now softly rewrites how your past feels, not in fact, but in flavor. Maybe you can't undo, but you can reweave. Maybe pain that once seemed permanent can fade into a wider pattern, because the thread you hold today curves backward to dot in the spiral of time. Nothing is ever fully over, and nothing is ever fully fixed, only touched, only heard, only folded gently into the next turning. As you lie here now, breath slow, eyes heavy, a thought begins to settle. The universe does not harden when you sleep, it softens. The stars above, the ones whose light you cannot see tonight, are still whispering photons toward you. The air around your body is alive with motion. Particles shift and scatter, uncertain of their place. The world, even in darkness, does not rest in certainty. It hovers, like you. You are part of that softness, part of a world that, at its deepest level, does not demand fixed answers, only possibilities. In the language of quantum mechanics, the state of the world is not a list of things. It's a field of probabilities, a wave function extending in every direction, describing not what is, but what might be, until something is measured, until something interacts, until some gaze settles on it. The world remains open, UNCOLAPSE, and maybe you do too. Maybe your thoughts, your hopes, your memories, they flicker with similar uncertainty. Not broken, not wrong, just unfinished. It's waiting like a photon before a detector, for context, for quiet, for presence. This is not a flaw, it's a gift. You are not here to solve every mystery before you sleep. You are not meant to make all the probabilities collapse before dawn. Some truths belong to dreams. Some answers take shape only in the softness of letting go. Physicists sometimes call quantum uncertainty a kind of fundamental fuzziness, high refusal of nature to be pinned down. The more precisely you know a particle's position, the less you can know its momentum. The more clearly you measure its energy, the more uncertain its timing becomes. It's not that reality hides from you. It's that it isn't yet. In the silence of night, that idea feels less threatening, more familiar. Because you, too, are still becoming. You are not the person you were this morning. Nor are you quite the person you wake up as tomorrow. You live in transition, always, shaped by what you see, what you feel, what you choose to notice. The wave of your life does not collapse until you decide. So, as you drift deeper, let go of needing things to be defined. Let the questions remain open. Let your breath join the quiet probabilities of the room. The flicker of air molecules, the invisible rise of heat, okay? The slow spin of electrons far beneath your skin. Everything is still happening. Everything is still waiting. And you are not late. You are not wrong. You are simply here, suspended gently in the moment before the world chooses its form. When morning comes, choices will return. Observations will be made. Interactions will happen. But for now, you are allowed to rest beside the uncertainty, not fixing it, not fearing it, only floating in its kindness. Perhaps this is the final lesson the quantum world offers you tonight, that not knowing is not the same as being lost, that open possibilities are not empty, but full, that even in silence, something meaningful stirs. So, close your eyes, let the wave continue. Let the dreams drift through every slit, every path, every version of the night, and whatever tomorrow becomes. Let it unfold gently, not as a verdict, but as a continuation.